Hello, my name is Sergio and I'll be presenting Turning the Tables, Biased and Balanced Dynamic Tabular Datasets for ML Evaluation. When it comes to evaluating fairness in machine learning, there is no clear choice on which tabular dataset to use. Most commonly used datasets in the literature are the UCI Adult, Compass, and German credit datasets. They have some shared issues, one being their size. They have documentation issues, and which is the case of the UCI adult dataset, it's not based on a real task. To counteract this, we present the bank account fraud suite of tabular datasets. These datasets are tabular, which is a format that is used in many high-stakes domains. Realistic, because they are based on a real-world dataset, which was used for fraud detection in bank account applications. They're biased. The original dataset had some biased patterns in the data, and we enriched the dataset with some controlled data biases of our own. Imbalanced, because the prevalence of fraud is really low. Dynamic, because it features changes over time on the patterns observed in the data. And privacy preserving. We applied some methods to promote privacy to ensure that no applicant information is leaked. Additionally, all of the datasets are composed of 1 million observations, 30 features, a column for months, and protected attribute information, in our case, age group, employment status, and personal income. With this suite, we provide a set of 6 challenges for your methods, and these are depending on the protected attributes. In our case, we selected the age of the applicant and the prevalence of the fraudulent instances. So the base data set was sampled to best represent the behaviors on the original data set. The first variant that we present, we have a higher prevalence of the majority class than the observed on the original dataset. In variant 2, we increase the prevalence for the minority group when compared to the original one. And in the third variant, we increase the separability for one of the groups, in this case, the majority group. Variant 4 and variant 5 is the variant 2 and 3 datasets, but only applied in train. So the test set doesn't have those disparities. We generated the datasets by selecting features from the original data, adding some noise, and then passing the resulting dataset through a generative model. The feature selection was used based on the 5 light GBN models. From these, we selected the top 30 features and we handpicked some of them. We used features that are composed of aggregations, so PYI data was not included in the final product. The noise mechanisms that we used was the Laplacian noise for numerical variables, and for categorical variables, we applied some noise according to the prior distribution. To obfuscate more the applicant age and income, these were grouped together. The generative model that we used was a CTGAN, which is a model that is adapted to the tabular domain, and we trained a total of 70 GANs using the random sample of hyperparameters. On the resulting datasets, we applied some filtering so that no instance from the original dataset was observed in the generated datasets. And we also applied some transformations to maintain some of the observed patterns in the original dataset. So, for example, we maintained the number of decimal places in all the features. We kickstarted the studies on this dataset with running an experiment with light GPM models. For each variant, we ran a total of 100 models. We can already observe that the behaviors are very dependent on the variants that we tested on, and the best models in one variant are not necessarily the best models in another variant. All the datasets and code are available in GitHub, so you can run the experiments just like we did, and feel free to test on the dataset. Feel also free to leave any question in the poster session about this paper. Thank you very much.